everyone. Thank you very much for having me. So yeah, as you say, the request here was for us to present a little bit about ourselves, a company based in the UK who have and will benefit from the offshore wind growth. So just quickly, a little bit about who we are. We specialise in the design, development and deployment of industrial sensors and data acquisition systems, and that's predominantly for the purpose of remote condition monitoring of high-value industrial assets. So our company was established in 1996 by our founder, Jarek Rosinski. He was travelling the world as an engineering troubleshooting consultant, working across various industries with mechanical engineering challenges and helping extract data from industrial assets to determine what those issues were caused by and how to best address them. As the company's established, we've moved towards developing sensors and data acquisition systems to extract that data remotely to save the consultants like Jarek travelling the world and getting information ad hoc. We'll be able to continuously and remotely monitor those assets. So the business is based in Cramlington in the northeast of England, and we have now a multidisciplinary team with all of the skill sets you can see on my slide here to address that challenge, to be able to use mechanical and electronic engineers, embedded systems, instrumentation engineers, to apply artificial intelligence and also the intelligence of our field engineers to develop R&D solutions and then to scale up through advanced manufacturing to deploy them globally. So our service offering, if you like, now is one of industrial Internet of Things solutions. So the bespoke sensors and acquisition systems I talked about, we use wireless data transfer systems. We use human-derived engineering analytics to inform the algorithms, machine learning algorithms, about what they should expect to see and understand from the data extracted from our technologies. And then we use artificial intelligence to let the data tell us what it sees, which obviously is a very exciting extension of the services that we offer. And then we use cloud-based automation to be able to send texts and emails to stakeholders to let them know exactly what they need to know, when they need to know it about their assets, so they can make informed decisions to better maintain their infrastructure. So we do this across a whole range of sectors, but of course we're here today to talk about the offshore wind sector. So just as a snapshot of the types of technologies that we deploy in the sector already. I won't go through these in detail, but we have everything from shaft eccentricity monitoring, shear pin load monitoring, yaw drive torque monitoring, crack propagation, tiny bugs that can be applied all over an asset to understand temperature, acceleration, strain, torque, a whole range of solutions, all based, as I said, around that kind of condition monitoring, understanding exactly how assets like wind turbines and wind farms are operating and how best to maintain them. I'll go into a couple of those in a bit more detail further into the slides. This one is just to say that, of course, there is a whole range of knowledge, expertise and technologies behind those things that I have just whistled through. If anything's of interest to people for any reason, please reach out to me after the session. More than happy to discuss those in more detail. This slide is just to give a feel for the clients that we are already operating with globally. So these are the sorts of people that we're working with to deploy those technologies at the moment. But this case study was really to focus on how we feel there are opportunities for companies like ours to grow as the sector grows. So essentially it's about being able to apply the knowledge, skills and infrastructure that we have available to us to helping the market address the challenges that come with the high growth. So of course for offshore wind, it's things like the fact that we have a growing size of wind turbines being manufactured, a growing number of wind farms being deployed around the world, further and further offshore, and that those things are making already costly operations and maintenance regimes even more costly, even more time consuming and arguably even more of a requirement. And that's just enhancing the need to lower the levelized cost of energy and indeed to extend the asset life of the aging infrastructure that's already in place and to extend the usable life of infrastructure that the market is investing in now and for the future. So for companies like ours who specialise in remote condition monitoring, there's a huge and growing demand and market to target our solutions at. There's a significant amount of investment, as Tom touched on in the last presentation, in research and development, in stimulating supply chain innovation to be able to support companies to address the needs of the market. I'll give you a couple of examples of how we've done that in the next slides. Obviously, huge global deployment opportunities, because the technologies that we develop for one wind turbine and or wind farm, perhaps on a reactive basis, is something that we can deploy globally on a reactive basis, to be proactive rather than reactive moving forward. So huge opportunities for scale up of any solutions developed there. And for a company like ours, the biggest win, if you like, from that high scale deployment is the enhanced intelligence that we get from the big data that comes from these sensors globally. So being able to feed the algorithms involved in artificial intelligence with more and more data provides more and more intelligence that we can pass on to the market for common benefits, and to be able to better reduce the costs of operations and maintenance and reduce the lifetime of these assets. So just a few examples. This is an existing product. We call it the bolt cap module. You can see the little unit sat on top of these M72 transition piece bolts. So this is a wireless bolt tension monitoring device. It enables us to send an automated alert if the preload of the bolt drops below a predefined level. So you can see some examples of the reason that there is a need for this product on the right hand side, that we do still see bolt failures and fairly catastrophic results, and this is despite the fact that the typical maintenance regimes are for somebody to physically, or lots of people to physically travel to every wind turbine every 6 months and tighten every bolt, and that's a kind of precautionary maintenance regime, because they don't know what the preload is of that bolt between every 6 months, and so they need to go regularly and check them, and yet still these failures happen. So you can see that just in this one product, there's a huge opportunity to reduce the cost of operations and maintenance, to reduce the time taken, and to increase the safety of these assets. We've actually just signed a distribution agreement last year with a bolt manufacturing company in Arizona, Copper State Bolt and Nut Company, and they are trying to instrument every bolt that they sell now to this sector. They see it as such a growth opportunity for the sector, for themselves, and of course for us as well. So some great opportunities there. This is an example of one of the areas that we have been able to get investment, and we have a consortium that are working on this UK-US bilateral project, and Transmission Dynamics is the lead UK partner. It's focused on optimal sensor placement for physics-based digital twins. Essentially, the challenge here is about understanding that, yes, there are a lot of technologies, a huge plethora of technologies available for condition monitoring of wind turbines and wind farms, but it's about understanding really where the most efficient and effective deployment of sensors can be valuable to the sector. So this project looks at, firstly, what information we can already get from SCADA and CMS systems. What do we already know is available? How can we use machine learning algorithms to enhance that through things like physics-based digital twins, to look at kind of predictive analysis and modelling of the future of the assets, and then to identify any gaps between the two. Are there any areas where an optimally placed sensor, bespoke for the purpose of filling that gap, will be able to give a clearer picture of the asset? And again, that's all about extending the asset life and reducing the cost of operations and maintenance. So a very exciting ongoing collaboration that's already reaping results for the industry. And then this is an example of a second innovation that's been driven by the market need. This is one that was being supported by the North of Tyne Combined Authority, our local authority, and also some stakeholders, private sector stakeholders. There's an investment programme to put £3.5 million into boosting supply chain growth and productivity. And so one of the needs that spun out from the optimal sensor placement project was to be able to affordably and scalably monitor towers and foundations for cracks and corrosion, so supporting structural integrity testing. Typically, the technologies that are available are very expensive. They're not very scalable, and they do need you to be able to monitor just a set area where you know that there's a problem already. What we're looking to do is have continuous, remote, holistic monitoring of towers and foundations using ultrasonic sensors to deploy guided wave across the turbine. So it's, yeah, a significant innovation. Again, it's been driven by the need to, I think, actually Tom called it innovative survey, one of the requirements for condition monitoring. This is exactly what we're trying to do with this project, and to be able to get ahead of anything that we can do to help maintain these assets and to be able to extend the life of them. So I hope that that's given you a few good examples of where our current and future product offerings will benefit from the growth of the sector. Thank you very much for inviting me.